Hello, Mrs. Smith here, and we are working on lesson 5.1, so still unit 5 functions, relating graphs to events. Remember, functions are all about different function families and their graphs. So we're kind of getting ourselves into the swing of some graphing. We've done some scatter plots, so now we're going to talk about interpreting, sketching, and then analyzing. So we're going to kind of do all three of these. So interpret, I guess would help there, sketch, and analyze graphs. So let's look at number 1. It says interpreting graphs. So the first thing we're going to do is interpret, and we are working on, I'm going to move this over a little bit, so page 252 and 253, if you ever had to look it up in the book, and we're going to interpret first. Interpret. All right, so it says commute. One student walks and takes a bus to get from school to home each day. The graph at the right, this one right here, shows the student's commute by relating the time the student spends commuting and the distance he or she travels. So as you can see, they sketched a graph, and we have to interpret what's going on. Whenever you're sketching a graph, time always goes on the x-axis. So time is always on the x-axis, and then total distance or whatever the problem indicates. Sometimes it's distance, sometimes it's altitude, sometimes it's speed, so you have to pay attention to what they're talking about. But they said relating distance would go on the y-axis. Notice in a sketch or an analyze, it is just very general. There are no numbers on the x-axis or the y-axis, and you do not have to put any numbers as well. Just indicate that the corner is the zeros, and then that is it. And notice again, mostly just quadrant 1, because most of everything you're going to talk about is going to be positive. So this is a student who walks and takes a bus to get from school to home each day. So we have to kind of interpret what's going on. So you can see they make some gains here. Time elapses, but total distance, not very much, kind of goes kind of slow. And then it looks like over time, they don't make any distance. Distance stays the same. And then here, they've got a short amount of time, but they make a great gain in distance. And then again, they have a little bit of time that elapses, and they don't make a lot of distance. So you always kind of relate both the x and y axis to what's going on. So here is describing what the graph shows by labeling each part. So here, this part here, and maybe I'll make it in red this time, is about the same as this part here. And what they say is this is a person's commute home. And here, because over time, a nice chunk of time, they don't make a lot of distance, we can probably assume that this person is walking because the distance increases slowly. Here on this part of the graph, notice that a lot of time elapses, and there's no distance gained. So we can assume that they're waiting to get on the bus because it says that they take a bus according to the directions. And then last but not least, in this part of the graph, it says that you've got not a ton of time, a little bit of time elapses, not a ton, but look at the total distance. You got a huge increase. So then we can assume that this is when the person was on the bus because the distance increases so rapidly in relationship to the time it takes. So we're going to do the same thing here. The graph at the right shows a trip home, from home to school and back. The trip involves walking and getting a ride from a neighbor. Copy the graph and label each section. I'm just going to keep my copy right here, but I would encourage you into your notes to copy kind of what's going on. I'm just going to save time and use this one here. So according to the directions, we know that this is a trip from home to school and back. So this is a day. So here it sounds like they were home. Here they go to school, and then here they're back home again, okay? And it says the trip involves walking and getting a ride from a neighbor. So copy and label each section of the graph. Whenever you're interpreting, I highly recommend, instead of trying to do arrows like this because it makes it so hard to read, you label each section of the graph with a letter. So this will be A, here will be B, C, D, E, F, and G. And this will make it so much easier to kind of understand what's going on. And here I'm going to do the same thing. A, B, C, D, E, F, and G. So as I look at this, we can see that they are going from home to school and back, and they both walk and they get a ride from a neighbor. So here I can see in A, it looks like time is elapsing. They're getting a little bit of distance, but not a ton. So according to the situation, it looks to me like they are walking to a neighbor's. So, because they're going to get a ride from the neighbor. So I'm going to say that they're walking to the neighbor's house. And I think I'll pick up a green color, and I'll say, okay, that they're walking to a neighbor's house and walking to the neighbor's house. All right. Next, here, the distance time elapses, but the distance doesn't change. So they're not traveling at all. They're probably at the neighbor's house waiting for the neighbor. So they're waiting at the neighbor's house. So there they are waiting at the neighbor's house, and let's pick up a yellow color here. So right here, they're waiting at the neighbor's house. Maybe they get there and they're still eating breakfast, or maybe, if it's a girl, she's still fixing her hair. She's fussing in the bathroom or something like that. All right. Next, you can see in part C, the time, not a ton of time elapses. You've just got from here to here, so not a ton of time. But boy, oh boy, look at the distance increasing. It's increasing quite rapidly. So this, to me, indicates that they are riding in the car to school. So they're riding in the car to school. All right, and let's pick up, and we'll put that in. Let's do pretty in pink, driving in the car to school. So riding in the car to school. Now, if you look at this next part, this D part, notice that a ton of time elapses. A huge chunk of time. But do they move anywhere? They don't. So that is when they're actually at school. So they're at school learning. Yay! Yay to school. Yay to learning. Okay. Then you can see part E. It looks like they've got the return trip going on, and it looks like the same as C, which would be riding in the car to the neighbor's house. So they're heading back, going back home. School is finished for the day. Woohoo, right? So we'll do that in pink and that in pink because it kind of matches. Next, we have this part right here. So it looks like they're waiting at the neighbor's house. Their distance isn't changing. They're getting out of the car. Maybe they are, this would make Mrs. Smith's heart nice and warm. Maybe they're like, hey, you know what? In math class today, we did this and this. Hey, do you understand your homework? Blah, 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 blah. Maybe it's all about what they did in algebra class. But in all reality, okay, I'm not a dreamer. In all reality, probably what happened is they're like, hey, I'm going to get on and play, PlayStation. So when you guys get home, log on and play with me. I'm sure that's what's happening. And who knows what the latest and greatest game is that you guys play together. But I'm sure that's really what's happening. But they are waiting at the neighbor's house. So. And last but not least, highlight that in yellow because it matches there. And then last but not least, we have that last part, and it looks like that they are walking home. So that is all about interpreting. Going from a sentence or two, I think this one actually had 2 sentences is all, and we were able to determine 1, 2, 3, 4, 5, 6, 7 parts of the graph from 2 sentences. So that's how you interpret a graph. So now let's move to the next one, and let's actually talk about a sketch of a graph. Oh, I'm probably going to have to move down here because that's where the page is. So we'll go here, sketch. So we're going to actually sketch this time. So here it says, a plane is traveling from New York to London. Sketch a graph of the plane's altitude during the flight. Label each section. So you've got gonna sketch a graph of the plane's altitude. Notice time always goes on the x-axis. This time they tell you altitude, so that's what goes on the y-axis here. Notice there's no numbers. It's very general. It's just 0. So as a plane goes, obviously this is where you're taking off. This is when, you're taxiing down the runway, you're starting to go, and the plane starts to lift off. Then you can see you're gaining a lot of altitude over a short amount of time. This is where you kind of lean back in your seat and you're like, whew, here we go. And then eventually you get to cruising altitude. This is where the pilot usually comes on and is like, we are now at cruising altitude at, such and such a feet. You can go ahead and take off your seatbelts. You can use the restrooms if you need to, and they'll be around for service with a little snack, something like that. And then you can see here, you're kind of losing altitude. And then eventually here you're circling the waiting for a runway, and then eventually you lose all altitude and you actually land the plane. All right, so kind of sketching a graph based on just this sentence. You're going from New York to London. You have altitude during a flight. That's all you need. You have to kind of interpret what's going on, sketch what's going on. So it says here, make a sketch of a distance from a child's feet on the ground as the child jumps rope. Label each section. So again, I'm going to kind of go like this. Just need a first quadrant. I'm going to put a title. All good graphs need titles. So jumping rope. Very general. What did I say always goes on the x-axis? Hopefully you are saying time. And then on the y-axis, it will tell you what it is. And in the problem, it says distance. So I'm going to put in distance. Now, we can be a little more specific. Think about time and think about somebody jumping rope. Think about what it looks like. So like right now, I'm moving my hands around in a circle. What would my feet be doing? They'd probably be just going up and down, up and down, up and down. So time here is probably seconds, so I can be a little more specific. And distance, are we talking miles? Are we talking feet? Probably not. Somebody's jumping rope, they're not getting very much time elapsed over there. So probably we're talking inches, maybe centimeters. That's probably it. So jumping rope, sketch what it might look like. Now, as you think, hopefully you did something like this. Maybe up and down, and then up and down, and maybe they got a big jump in here, and then up and down, and then up and down, okay? Now, if I do this in class, I essentially always see somebody do this, and I'm gonna just kind of draw it in here like this. I see something that people do this, okay? Remember that this distance is 0. So that's the ground. If you sketch something like this, these people are levitating. They're not touching the ground. Whoops, that can't happen unless you're David Blaine, I guess. And I think, still it's all an optical illusion. So that cannot happen. So therefore, you have to touch the ground each time. So kind of keep that in mind. So now we have that. We've actually sketched the graph. And now we have to label what's going on. And again, just like I did before, I'm going to label with letters. And I'm going to do something here. Instead of doing each one separately, I'm going to call these all A because they all mean the same thing. And A would actually be what? What's happening? They're jumping up. And they're doing it quickly. And I put the word quickly there because it relates to time. So they're doing it quickly. They're jumping up in the air quickly, okay? And so that's this part here. And let me pick up, let's pick up a yellow. And let's say all of these are yellow. Yellow, 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 yellow. Okay? I could also then pick up, and let's label all of these down here, B, 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 and B. And what's coming down? Or what are they doing? They're going down from the jump. So they're coming down from the jump. And let me pick up a color. Let's do those in blue. So here, 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 and here. So they're coming down from a jump. I could technically put one more spot in here, or a couple more spots in here. I could do C, 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 and C. And C would be the highest point of the jump. Highest point of the jump. And let me pick up orange for that. So highest point in the jump, here, 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 and here. And I could probably put in one more, and that's here, D, 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 and D. And D would be what's happening there? They're landing on the ground. Now, remember when you sketch, you always have to definitely give a description of what's going on. So don't forget that description. And let me pick up, I'll do green again. And then here's D, 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 and D, landing on the ground. Okay. All right. So sketch with a description and labeling, telling me what's going on. All right. And the more the label, if you're more specific, it can't hurt. Okay. Last but not least, we are actually going to now do the last part, which is to analyze. Whoops, 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 whoops. So let me erase that first and then analyze. A-N-A-L-Y-Z-E, analyze. Okay, so it says relating graphs to situations. So suppose you pour water into this container at a steady rate. Which graph shows the change of the height in the liquid in the container over time? So imagine yourself, you've got a little pitcher here, and I'm not a good artist. So here's my pitcher with my handle, and I have some water going in, okay? Notice that it's going to fill up here, and then it fills up a little bit more, and then it's kind of, steady as we go. But notice here, this was a little narrower, so the water is going to actually fill up quicker at this point. Notice that it says time and then the height of the liquid. So notice it says time, 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 and then height, 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 height. You always get the Y from whatever it says in your description. So here, it looks like this is going to go fairly quickly. And then as we have a wider part of the thing, it kind of takes longer to fill up. And then it kind of, there's not a lot of difference between here and here on those edges. So then it starts to level off. So which does this show? So this shows that you kind of fill up over time. The height goes kind of quickly, and then starts to level off. This one starts to go quick, level off, and they'll go quick again. This one is just steady over time, and this one goes really slow and then really quick. So the one that started up going really quickly and then kind of levels off would be A. And that's what it says. The rate the water rises will decrease steadily because the container gets wider from the top to the bottom. So A is correct. Now, if we go back to this one, think about it. It went quickly, then it leveled off, and then it went quick again. What do you think that container might be? So kind of went quick, so kind of maybe like this, and then it went quick, and then it leveled off, and then maybe it went quick again, leveled off, and then went quick again. So maybe even something like this, like an hourglass type shape for B. C might have been, it says it was just steady over time. So I bet you C is some kind of cylinder that's exactly the same all the way through. And then D said it went really slow and then it went really quick. So that means this is going to be really big on the bottom and then maybe it kind of levels off like this. So it went, it went really slow at the bottom. Yep. And then kind of levels off and kind of fills up that way. So maybe something like that. All right. So last but not least, let's analyze. It says the graph on the right shows the time and distance. So time, and here's your distance, which is your Y, of a moving object. Which of the following situations could be described over the graph? It says a car travels at a steady pace. Okay. Steady pace. This is distance. Or not a steady pace, a steady speed. This is distance. This is speed. that might be an issue, but let's look. It travels at a steady speed. So if the speed is going, would the distance be steady as well? Okay. It says a cyclist slows down as he or she rides up a hill and speeds up as she scuttles over the top. Well, we don't have any, speeding up and then pedals over the top. We don't have any change. So this is just a steady. So I don't think it's going to be G. A train slows down as it arrives at the station. This talks about distance and it's increasing. I don't think anything's slowing down, so that's not going to be it. A plane accelerates steadily down the runway until takeoff. So steadily and then takes off. What do you think is going to happen to the distance as a plane takes off? It's going to increase rapidly, so it's not doing that. So F would be the best situation. And even though it said speed here and this said distance, we have to think of how those two might relate. And if you're going at a steady speed, would your distance also increase in a steady fashion? And it would. All right, so relating graphs to events, interpreting, sketching, and analyzing.